Hello, everyone. Welcome to today's session on electricity. So in electricity, we will look at electric current. Okay, so electric current and circuit. So first, let's understand what is electric current, right? So electric current is an essential thing in our day-to-day life, right? So in our household, everywhere, wherever we go, we need electric power, right? Electricity. So what is electricity, right? So electricity is denoted by a letter capital I. Okay. So what is electricity is the rate of flow of charge, right? So if you have learned in your earlier classes, every material is filled with molecules, and those molecules consist of charges, particles, right? So the charges can be the positive charges and negative charges. So if you look at positive charges are protons and negative charges. The negative charges are electrons, right? I think you guys know this, right? So a matter consists of particles. That particle is compound or made up of charges, right? So the positive and negative charges. So the negative charges are called electrons. So all together is a charge, right? So it can be a positive or negative charge. But what is electric current is the rate of flow of the rate of flow of charge. So it is the rate of flow of charge. So here charge is denoted by capital Q. So charge is denoted by capital Q, and its SI unit is coulombs. So that's a capital C that we can call it as coulombs. Okay. So the charge is denoted by capital Q and the SI unit is coulombs. So what is I? I equal to rate of flow of electric charge. The rate of flow of charge or electric charge, you can say, right? So what is rate of flow? Means the amount of charge that flows in a certain time. Let's say T is the time interval, then I we can say as Q by T. Okay, so what is I? I is Q by T, the rate of flow of charge. So what is the rate per time? Like for example, in 10 seconds, 10 coulombs of charge is flowing, then we can say it is 1 amp current is flowing through that. So here I mentioned amp, right? So let's learn what is this. So I equal to Q by T or Q equal to I into T. This is the formula for finding the electric current in a particular circuit when a Q amount of charge is passing through in T seconds. Okay, now what is the unit of electric current, right? So what is the SI unit of charge? That is coulombs per. What is the SI unit of time? That is seconds. So we can say I units, right? Are SI units of I or current or coulomb per second, or we also called as capital A, which is ampere. So the SI unit of electric current is amps or ampere. So whenever we see on a battery, right, on our battery cells, we will see 5 amps, right? 5 amps, 4 amps, 10 amps, like that. So that is the amount of current that battery can supply. Understood? Okay. So what is the SI unit of electric current? That is ampere or coulomb per second. Okay. So in so for it's basically the flow of charge, basically flow of electrons. Okay, let's say I have a circuit here. We will learn more about the circuits here. Okay, so let's say I have a bulb here. Okay, let's say this is a bulb connected to a battery. So battery we can denote using the long vertical line versus the small vertical line. And let's say this is connected with a switch, okay, for connecting and disconnecting. And then it is connected to, let's say, A, that is called ammeter. Okay, so uh, when we connect a wire, a conductor to a battery, automatically the electrons start flowing. So the electrons will start flowing from negative terminal to the positive terminal. That's the flow of electrons. Okay. Then the current will flow in the opposite direction to the motion of electrons. So that is I. Let's say I amount of current is flowing through these circuits to lit this bulb. So here what we are learning is, for a circuit, we need the source of electric current, that is a battery cell. And then we need a conductor which can connect to both the terminals of a battery, and then a consuming device. For example, here it is bulb is the consuming device, and then how much current is flowing, that can be controlled using the switch. Switch symbol is this. So we will learn about the symbols that we can use in circuit in our uh, next slides. Okay, then this is A is ammeter. So this is the full set of circuit. And if the switch is on, then the electrons will flow in this direction. That means the current is flowing in the opposite direction. That is from positive terminal of the battery to the negative terminal of the battery. So that is electric current. So what we learned here, the electric current is the rate of flow of electric charge, particularly the electrons. Okay, if electrons flow in one direction, the current flow will be in the opposite direction to the flow of electrons. Now, what is the formula for calculating I equal to Q by T? Whereas Q is the amount of charge that is flowing in T seconds. And the units for electric current is coulomb per second or amps or ampere. Okay, so, and what else we learned here? So current, electric current I can be measured using, we can measure electric current using ammeter. The device that measures the electric current is ammeter. And also ammeter always connects in the circuit in series. Okay, just remember for now what is series. We will learn more about what is a series connection and what is a parallel connection. So for now, you just remember ammeter is always connected in series in a electric circuit, always connected in a series. So here what we learned is, what is electric current? That's the rate of flow of electric charge, and the formula is I equal to Q by T, and the units are, the SI units are coulomb per second or amperes. Okay, that is denoted by capital A. And electric current can be measured using ammeter. And also ammeter always connects in the circuit in a series manner. Okay, it is connected in series to measure the amount of current flowing through that circuit. Okay, so that's an electric current. Hope you guys understood. Now let's look at a problem here, like how to calculate the amount of current flowing in a circuit. Let's say this is an example from your textbook. A current of 0.5 amps, capital A means amps or ampere, is drawn by a filament of an electric bulb for 10 minutes. So here, what is given? So current is given. I is given. I is 0.5 amps. And also time T is given. That is how much? 10 minutes. But in SI units, we always measure the time in seconds. So let's convert this into seconds. So 10 minutes means 1 minute is 60 seconds. So 10 into 60 seconds. That is 600 seconds. Okay, so we have the time now. Find the amount of electric charge that flows through the current, to the circuit. Sorry. So what is I? I equal to the rate of flow of electric charge. Now Q equal to IT, or yeah, I equal to Q by T, on Q I can write as I into T. Now I need to find what is the amount of electric charge that is flowing through this circuit. So I know current and I know the time, how much time that electric current is passing through that circuit. So what is I? I is 0.5 into time is 600 seconds. So that means this is 6 into 5, 300. 300 coulombs, I can say. You understood? So how much charge is flowing through this circuit? 300 coulombs of charge is flowing through this circuit. So that we can say. Understood? So these type of problems can be asked in the board exams. Okay. So we learned about electric current and we also worked one example on how to find the amount of current. See, here they ask to find the charge. Sometimes they give the amount of charge and the time. They will ask you to find the current flowing through the circuit. So in that case, you can just apply I equal to Q by T. Q you know and T you know. Then if you substitute, then you will get the value of amount of current flowing in the circuit in amperes. Okay. All right. Now, next, yeah, let's move to the next concept. What is electric potential and potential difference? Okay. So, for example, if you consider there is a pipe, okay? There is a pipe which has water in it, for example, and it is standing horizontally, okay? When it is standing horizontally, the water will also be stagnant. It will not flow. So what is required for the water to flow? Some push is needed or some pressure difference is needed. You understood? So let's say if I connect this to a tank, if the same pipe, if I connect it to a tank, what will happen? This is the water tank, for example. This is the water pipe. Let's say this is also water. Now, when the pipe was not connected to the tank, the water is stagnant. When I connect it to the tank, there is a more pressure here, right? More pressure P here than the pressure here. Let's say this is P1 and this is P2. So what will happen as P1, the pressure in the tank is greater than P2, the water starts spilling out. You understood? So for water flow, what is required here? A difference of pressure is needed. Understood? A difference of pressure is needed, and that is provided by the water from the water tank. Now, similarly, for electric current, the electrons will not flow on their own. So electrons need a push, like how water needs a push. Electrons also need a pressure difference. That pressure difference is nothing but the potential difference. Hope you guys are following, right? So I have a battery here, okay? Let's say this is my battery, okay? So if the battery is connected to the terminals, if the battery is connected to the terminals, then what will happen? There is a current carrying conductor and let's say there is a bulb here. There is a switch. Hold on. There is a switch and here I'll connect some device. I'll tell you what is that. Okay. Now this is the battery, the positive and negative terminal, and the current carrying conductor or a wire, and then that's connected to a bulb, and across that bulb I have connected a voltmeter. Okay, I'll tell you what is it, and then a switch. Okay, now whenever in a battery you have two terminals, right? Positive terminal and negative terminal. So you know the batteries, right? Batteries are the ones that we use in the TV remote, right? Or in a torchlight. So those are the batteries. If you see that battery always has a plus and minus, right? Let's say this is your battery cell. This battery cell always have a positive and negative terminal, right? So here within this battery cell, a acid and some chemical is filled. That chemical energy will convert into electric energy that will give the push for the electrons. Okay, so when we have plus and minus here, the accumulation of electrons will be there. There will the battery itself has created a pressure difference or a potential difference between the positive and negative terminals. So majority of the electrons are accumulated at the negative terminal, which is the smaller line here, smaller vertical line. So the moment you connect a electric conductor, those electrons starts flowing into that wire. So whenever there is a charge flow, there is an electricity flow that is in the opposite direction. You understand? So that's how the current flows in the circuit. So if the current flows in the circuit, then we can measure how much of the potential difference present at these 2 points in that circuit. So potential difference is always measured at 2 points. Okay, potential difference is always measured between 2 points from point A to point B. Let's say this is point A and this is point B. The potential difference VAB, the potential difference at 2 points AB equal to VA minus VB, the potential difference. The potential at A minus the potential at B. So the potential difference is measured using voltmeter. Okay, the potential difference is measured using voltmeter. Now, what is potential difference? So the potential difference is denoted by capital V, right? So the potential difference is the amount of work required, the amount of work done or required, work done to move a unit charge, to move a unit charge. So what we said, the charge, the electrons will not move on its own. It needs a push. What is that push? Is the potential difference. So what is that? The amount of work done to move a unit charge. So V I can write as W by Q. Can write that. So work done per unit charge. So if Q amount of charge needs to be moved by doing a W work, if W amount of work is needed to move Q amount of charge, then the potential difference V can be calculated using W by Q. Understood? So then what are the SI units? So what are the SI units of potential difference is work done. Work done, what is the SI unit of work done? That is joule per, what is the SI unit of electric charge? That is coulomb. So we can say joule per coulomb or volts. Or you can just say V. Volts can be denoted in the form with a letter V. So whenever you see a battery cell, that will be denoted with 5E. Means that battery cell will give you a potential difference of 5 volts. That's what it indicates. Okay, 3 volts, 10 volts, like that. So what is potential difference? The amount of work done to move a unit charge. That is V equal to W by Q, or the work done we can write as V into Q. Understood? So capital Q is the total amount of charge. If it is, we are just talking about a small charge, then we can also write this as W by small q. Or this we can write as W equal to V into Q. Okay. So it is basically the amount of work done to move a unit charge or Q amount of charge. If it is Q amount of charge, then the potential difference V equal to W by Q, and its units are joule per coulomb or volts. And one thing we need to note here is earlier ammeter was connected here, right? So that is connected in series. But here, if you see the voltmeter, it is connected between the 2 points. That means it is connected in parallel, not along with the current flow. It is connected in parallel. So voltmeter always connects in parallel. Okay. Just remember, we will learn what is a series connection and parallel connection in the later session. Okay. So what is the potential difference? Potential difference is the amount of work done to move a unit charge. And the formula is V equal to W by Q. And the SI units are joule per coulomb or volts. And this potential difference can be measured using the device voltmeter. And voltmeter always connects in the parallel, as a parallel connection in the circuit. How about the ammeter? Ammeter is to measure the electric current, and that always connects to the circuit in a series connection. Okay. All right. So now let's look at this example. So how to find or solve the problems with the potential difference. How much work is done in moving a charge of 2C, means 2 coulomb, across 2 points having a potential difference 12 volts. So what is given here? Q is given. So Q is 2 coulombs, and the potential difference, capital V, is given, that is 12 volts. Now what we need to find? The work done we need to find. What is W? W equal to VQ. How we got that? V is amount of work done per moving a to move a unit charge. If Q is the amount of charge, then W equal to V into Q. So what is V here? 12 volts into what is Q? 2 coulombs. So 12 into 2 is 24 joules. So the amount of work done here is 24 joules. Okay. So we learned about electricity, what is electric current, and then we solved the problem on electric current, and then we learned what is potential difference and solve the problem. Now let's look at what symbols that we use to draw a circuit. Okay, so for a circuit, what symbols that we can use? If you look at this is from your textbook, right? So the electric circuit, the symbols are for electric cell. We have been using this, right? You have a positive terminal and you have a negative terminal. Both are vertical lines. The bigger vertical line is your positive terminal, and your smaller vertical line is your negative terminal. So this is the indication of a battery cell. Okay. Now a battery or a combination of cells. So if we have one or more cells joined together, then how we can do? It will still have one positive or negative terminal because this is connected in series. These cells are connected in series. If you guys have a torch light, so the torch light have this type of connection where you will put 2 or 3 batteries, one after the other, where the positive terminal is connected to the negative terminal of the preceding battery, like that. So this is a combination of cells. We can denote like this. And a switch, when the switch is open, we use this symbol as well, right? So this indicates the switch is open. When the dot is there in between, that indicates the switch is closed. So when the switch is closed, then there is a flow of electric current. When the switch is open, that means it is in the off state. So whenever we need a fan, what we will do? We'll turn on the switch. So what does it do? It sends the current to the appliance. What is that appliance here? Fan. So when fan gets the electric current, it starts working. So what is the controlling point here? It is the switch. So here, open switch means it is in the off position. Closed switch means it is in the on position. You understood? The switch is open means it is off, no current is flowing through the circuit. When the switch is closed, that means the current is flowing through the circuit. Then a wire joint. So if you want to make a joint to the wire, you can use this symbol, right? Now, a wire is crossing but not as a joint, then you can indicate like this. So they are like overlapping on each other, but they are not connected. So you can use that symbol. And bulb we already used. So bulb you can just indicate like this, right? And then a resistor or resistance. We will learn about resistance. So at that time I'll tell you. So the symbol for resistance is this, okay? And then variable resistance means it can vary by different devices are there. I'll tell you. This is variable resistance, or we can also indicate like this. Okay, this is the symbol for the variable resistance. And then ammeter we already used in earlier circuit. So A, this is ammeter. So how ammeter always connects? It connects in the series. And then voltmeter. So voltmeter we can connect like this. So here plus and minus is given because this wire connects to the positive terminal in the circuit and this connects to the negative terminal. Understood? So these are the various symbols that we use in electric circuits. So wherever you see this symbol, that means it is a resistance. Wherever you see a symbol, and that means that's an ammeter to measure the amount of current flowing through the circuit. Okay. So hope you guys understood, right? Okay, let's do a quick review. So in this session, we learned what is electric current. It is the rate of flow of electric charge, and that is I equal to Q by T. And the SI unit is coulombs per second or amperes. And it can be measured using ammeter, and the ammeter always connects in a series. And then we learned about what is potential difference. Potential difference is the amount of work done in moving a unit charge. If Q amount of charge needs to be moved, then the work done is W, then V equal to W by Q. And the SI units are joule per second or volts. And this potential difference can be measured using voltmeter, and it is always connected in parallel in the circuits. Then we'll did some problem, and then what different symbols that we use in a electric circuit. Okay, so that's all we learned. So I think that's all for today's session. I hope you all understood the topic, and I'll see you next time. If you have any doubts, please contact me through my Urban Pro profile. Thank you.